Right. So this is the reason I've missed the speaker dinner yesterday, right? I was seeing this mountain. I really wanted to kind of go upstairs and started to way too late. Anyway, made it. So this is my first time in Macedonia, and I kind of came in a few days earlier to check and explore things. And I was taking in all the things that this country has to offer. There was this wonderful mix, right, of tradition and modernity, and long history of the country, but also the country that is formally very, very young. And all those things kind of made me reflect about the Angular journey. And Angular isn't exactly a new framework, right? We've been around for over 10 years. And I guess in the JavaScript framework, years is just entire, it's eternity, basically. But we've been also going through kind of renaissance of our own. So in the last 3 years, we did massive changes to the framework. The rendering engine, the core that put the pixels on the screen, is powered by the signal-based reactivity now. This allows us to make Zone.js optional, modernize the overall architecture, and speed up the rendering process considerably. On the server front, we moved from the framework that was really focused on the client to the one that takes full advantage of the server capabilities. We've introduced super innovative partial hydration, where the content is produced on the server, which is kind of obvious, but then the client-side code is downloaded and executed only as needed, only for the parts of the applications that needs to wake up. And this happens, the code download and execution can be delayed to the first interaction or some other interesting moments. So reactivity and server-side storage, those are deep architectural changes that take years to plan and execute, especially for the framework that is having a rich ecosystem and when you want to bring people with you. So to keep things fresh also on the kind of authoring side or on the surface side, we also invested in the quality of life improvements. Here's the shout out to our new authoring, or parts of the new authoring format, specifically the control flow, which people appreciate very much. Now, obviously, Angular was always firmly in the framework territory. So it's not only the rendering engine, we've got the whole suite of things around the framework. And we do have tooling, and tooling did evolve with the framework as well. Lots of things that changed there, but shouts out to two of my favorites, or two recent developments. Here you see the signal graph, which is basically looks at the entire data flow of your applications and visualizes it. Something that is probably hard to picture in your head sometimes. One of my other favorites is kind of stepping outside of the pure Angular territory and integrating with the Chrome DevTools performance panel directly. So Chrome opened up new APIs recently, and we took advantage of them to introduce Angular Custom Track, where you can see how your components or services or lifecycle hooks kind of influence the performance of the application. And this is visualized right next to the standard flame chart, so you can zoom in and zoom out on the different level of details, right? Either see Angular side of things or just drop down to the pure JavaScript function calls. Long story short, Angular evolves very significantly in the recent years. And if you tried the framework several years ago or didn't try it at all, I would highly encourage you to do so because this is very much refreshed now, and you might like what you see. Now, you can probably see that I'm excited about all those things that we've been shipping and we've got kind of on the drawing boards. And I guess it's not a surprise because I'm working at Google on those things every day. I'm Pawel, and I couldn't be happier to be with you here. Now, when I was thinking about this talk, I could easily fill in 30 minutes talking or kind of diving into the details of all those things that we've been shipping or all those things that we are planning to do. And that would be very easy to do. But we have to acknowledge that all of a sudden we've got new colleagues in our industry, right? LLMs are writing code side by side with us. help us execute developer workflows, review our code, per program with us, do all sorts of mundane tasks, and being useful in many different ways. And those new developers might have very, very different idea about what to expect from the framework and applications that are built with this framework. So I thought that instead what we will do is to kind of look at the framework of the future in this that is really prepared for the era of LLMs. And I kind of get what you might be thinking now, like, oh, well, another AI talk. And I was kind of skeptical at the beginning. So Bing and Google put you in this very front seat row when it comes to AI and the LLMs. And for me, this whole story started with emails. I was kind of getting lots of those emails that were looking roughly like this, like lots of text, AI, text, AI, Gemini, and so on. And at the beginning, you get those emails, you get interested, you try out things. But to be honest, I was kind of underwhelmed. I don't want to say not interested, but just those tools were kind of not working for me. But then one day, things were evolving, and new models were arriving, and new tools were arriving. And I remember vividly coming back home one evening and telling my wife, hey, there is something in it, right? Like, those things can program really, really well. Well to the point that, as well as my colleagues or myself. So, that was the moment where, like, okay, that's interesting. So with this new, I won't say enthusiasm, but it's like, okay, hey, there is something in it. We started to look at the team purely on the Angular code generation, right? And I'm sure that you've tried it, and many teams at Google tried. And to our surprise, we're getting very mixed results when it comes to Angular code generation with different tools. Some of the tools, here's the screenshot from Gemini Canvas, generating a 2D application. It was spitting out like perfect modern Angular code, like signals, modern API, working first shot, like nothing to complain about. But then I was trying other tools, and the results were like underwhelming, right? Like sometimes LLMs would do hallucinate APIs that don't exist, or use some old deprecated APIs. And in some cases, they would like straight out refuse to write any Angular code and give us React in response. So this was extremely confusing, right? Like, why do we see such difference? We couldn't kind of pinpoint of what's going on. Is this that our prompting techniques are not good? Is it because different models were trained on different frameworks? Or maybe those are the tools that put something specific in the workflow that make them better with one framework versus the other. And that's obviously, it's a not great feeling when you don't understand things as engineers. So to kind of make sense of the situation, we built a specific tool, a kind of laboratory environment in which we could exercise code generation in kind of, very constrained setting. So let me introduce you to the LLM eval tool that we've created internally in the Angular team and open sourced recently. And then, as I said, we've created this tool to better understand the whole generation pipeline for the code. We did it for ourselves, but we open sourced it because we believe that it can be useful for other teams and web ecosystem in general. Now, what is this LLM eval tool? It essentially takes hundreds and hundreds of small prompts, like 2 or 3 sentences, to generate a component or maybe a small application. Here's the example of such prompt and the kind of resulting application that runs in a browser. So you get those hundreds and hundreds of prompts, and then you shoot them directly at the model, right? Like we essentially built a silly LLM kind of tool of our own. And you shoot those prompts to the model, the results come back, and when they come back, you try to run a lot of checks on the code. You do static checks, like does it compile, like all the linting checks, is it using modern APIs? If it compiles, then you load it into the browser and see if it runs without errors. Is this functioning correctly? Then you take screenshots, check color contrast, maybe some other accessibility checks. lots of different checks. And then you combine those checks with different weights and like coming up with one number that is somehow representative of quality of the generated code for a given prompt. Then you combine those numbers across those hundreds and hundreds of applications, and you kind of like arrive to one number of some score. Now, you do this every single day, and you kind of like tune prompt, change maybe things in the frameworks, and see how those things evolve over time. Now, if you look at the Angular numbers, we are seeing that around 99% of applications are compiling straight out from what LLM is generating. Of those like compiled applications, 99% will run correctly in the browser without any errors. Now, if you ask me, those are pretty impressive numbers, especially given kind of non-deterministic nature of LLMs. So I guess the takeaway here is that LLMs are really great at generating Angular code, right? They should be totally sitting with us here as part of the Angular community, wearing Angular t-shirts, and so on. It obviously doesn't mean that they are perfect, right? Like from time to time, they will hallucinate the APIs that don't exist, or kind of use the older APIs, or do some other silly mistakes. But I guess it's okay, right? Like we do it from time to time ourselves. So the LLM eval tool help us to understand what's going on with the Angular code generation, right? Like we know that it's not the model that was trained on some like other framework, or maybe that the model has something specific to a framework. It's really good at generating Angular code. But again, like it was useful for us, and we thought it would be useful for others, hence the open source story. But we did more than that. We started to talk to other frameworks, specifically to Solid.js folks, and we asked them, hey, plug your framework into the tool and see what comes out. And Solid is interesting because it uses very different authoring format. It's very close to React, but it's not React. And what we are seeing from Solid.js is that like LLMs are doing extremely good with it as well, right? So I think the lesson here is that LLMs are just good programmers, right? Like there is nothing specific in a model themselves that make it favor one framework over the other. Now, coming back to this 99% correctness results, how did we get there? Like we didn't start with this number, but that was evolution. And what is behind this number? How this evolution happened? The biggest ingredient really is a prompt. And I'm not talking about the prompt that like you put here in the screen, like this one sentence or 3 sentences. In the sense, I think like when I was starting, this kind of toying with the LLMs, I was assuming that like, I get this prompt and this is exactly what LLM is hearing and going to follow. In reality, though, the huge part of the context is pre-appended to what you put in the chat window. So when you type build to the applications using Angular, this is combined, or like, the so-called system prompt is pre-appended to whatever you put in the chat. And those system prompts are kind of behind-the-scene instructions for the model to generate code. And those system prompts tend to be huge. Like, to give you like kind of order of magnitude idea, they can easily go into thousands of lines of text. So our prompt is kind of tiny in comparison to a system prompt. And the system prompt will target a very specific framework, right? Like it will say like, hey, write an application using framework X. It will also go to like find details of the best practices of generating code with a given framework. It will list third-party libraries that the tool should use. It will talk about the CSS that kind of well integrated in the framework. Long story short, system prompts have dramatic effect on the final outcomes from the model. And they can very easily override whatever we think we are telling the model to do. Now, creating a good system prompt requires substantial work, and usually it's best done when framework authors collaborate with tool authors. Right? Like we use this LLM eval tool to fine-tune the prompt over the several weeks, since we're running the tool every single day, we could see how changes kind of like impact the code quality. So we did partner with several teams at Google to embed the system prompt directly in the tool. You've seen the screenshot from Gemini Canvas. Here's another one from Angular AI Studio. And different tools will have different way on configuring those system prompts. Gemini Canvas will pick up the framework name from the user prompt, and AI Studio kind of lets you choose the framework from a dropdown. So we've got specific UI. Some other tools that don't have Angular integration yet will pick up some configuration files from your project. That's why from like Angular 20, I believe, the ng-new command, the command that scaffolds a new project, will have AI configuration at the root of the project. If you happen to have an existing project, ng-generate AI config will do the same thing that is at the config. Now, there's lots more going on when it comes to configuring those system prompts and configuring tools and so on and so on. So we've spent quite a bit of time on fine-tuning this process, and we put everything we've learned on this Angular dev /AI. So if you don't want me to lose voice, I need to have a drink. Okay. So up to now, I was mostly focusing on this single shot generation, right? Like you just kind of trying to get the perfect code from your prompt, like the code that compiles straight away and so on. And we kind of know that this is not how we work, right? Like it's pretty rare that we say like, oh, this is the feature to implement, and just kind of type it in perfectly the first shot. Also, there is much more to coding than just writing code, right? And I guess this gap of what we do every day as developers is very visible in the vibe coding platform, right? Like the vibe coding platforms let you start out of nothing, right? Like there is no setup to do, there are no choices to be made up front. You just go to the tool, you've got the prompt window. So it's very easy to set up and get started. Then you can express your intent and you get the running application. But what happens in between is there are like so many decisions taken for you, right? Like what is the framework to be used? What's the architecture of the application? What is the CSS library? What are the visuals and so on? And this workflow is great for getting initial prototypes or communicating through prototypes, or even getting your ideas out of your head. But again, we know that this is very different from our day-to-day job, and we know that there is a long way from initial prototype code to the application that is deployed in production and maintained over the years. So on this other side of the spectrum of vibe coding, we've got something that we started to call precision engineering. And again, this is pretty much the stuff we do every day. We will more often than not modify the existing code instead of creating the new one. We would spend time testing applications and debugging and deploying and taking care of the CI and so on and so on. And the AI tools of today, or at least those vibe coding platforms, are not really covering this full spectrum of the workflow, at least not today. Yet, as the days, those days where the AI agents might be able to fulfill all those tasks might be closer than we think. And I'm saying this because the technical recipe for enabling those workflows is relatively simple, right? Like you essentially need to have a workflow, give AI agents ability to follow the same workflows that we do, and give them the same information that we have to accomplish the task. So there are so many interesting problems here, but today I just want to focus on the workflow bit. So if you look at the entire AI ecosystem, there's obviously a lot of going on in the models itself and the capabilities and the way they generate code. But there's also the whole ecosystem of tools being built around the AI. And this is kind of fascinating time because it's not very common or it's not very often that we see this new ecosystem being built. We've seen it in the past with Node.js and APM, where we get from nothing to the whole like repository of packages that we use every day. And so we are kind of like witnessing the same thing for AI. And obviously the system is very new, it's very bubbly, it's changing every day. So it's super hard to know where we're going to end up. And yet we know that Angular will have to fit into this ecosystem. And I think there are few kind of touch points and integration points that are interesting. So what does it mean exactly? Well, we are pretty used to creating framework and the tools around it and documentation around it for human developers. We're also pretty used to doing tooling and automation, right? Like we've got Angular CLI, we know how to run tests, on the CI and so on and so forth. But as I mentioned, we've got these new colleagues that also want to interact with the same code and the same tooling that we are used to. And in a way, AI agents have the same needs. They want to execute the same task as we do, but they often don't have access to the same information or want to interact with this information in a different way. So if you were using one of those vibe coding platforms or maybe just agentic workflows, you can see that sometimes like AI agent just simply cannot get to the information that we've got. And they will often say like, okay, well, like I did some change, I tried to test the change, but I'm not seeing the error. Can you copy and paste it for me? And that's kind of silly, right? Like the AI agents should be automating our tasks. We shouldn't be automation for the agents. We shouldn't be copying, pasting code for them. So that's, again, like that's not fun. We want to do better. And I guess this kind of puts us into principle that we're trying to follow in terms of building tooling for AI around Angular. And the principle is that any capability that a developer has or access to any information the developer has, an AI agent should have as well. Which means that, again, LLMs should be able to follow the similar work from us humans, but interact with those tools and information in probably different way that is best tailored to their way of operating. So I have a kind of short demo of how this kind of complete workflow of the future might look like. How can I make it go? Right, so we've got our Angular Store application that is our demo application that we use for many different things. And we said, well, let's introduce add to wishlist functionality to this store application, right? Like you click on the star, and then we've got dedicated wishlist page. When you click on the star, you should go to this wishlist page and whatever, see the products that were added here. So this is the prompt that we're essentially trying to ask Gemini CLI, hey, implement this functionality for us. Then Gemini is going, finding the existing service where it needs to code, this kind of figuring out which files needs to be modified, and it does the modification. So you see the code div, well, it's kind of pretty reasonable, right? Like that's probably what we would do. Then after making the change, it opens up the browser, navigates, kind of interacts with the page, navigates to the star functionality, clicks on it, go to the wishlist page, bam, nothing happened. Well, so agent worked, but didn't quite work out. Now what's happening, there's no error messages, but the agent is kind of trying to figure out what might have gone wrong. So it's checking the UI graph and notices that the wishlist service is there kind of multiple times. So it kind of ideates, well, that maybe that's the root cause of the problem. After, with this hypothesis, it kind of figures out which files needs to be modified to change the service, so kind of reconfigure the service in a way that it is provided only once. It does the modifications. Confirms that the DI graph looks good after the modifications. And again, testing the application. So, the drill right now, right? You go to the page, you find the product, you start it, you go to the wish list page, long scroll, long click. Ta-da, or not? Yep. Okay, we do have a product, which means that kind of like the agent could figure out what might be wrong. It even, clicks on the star again to confirm that that works the other way, right? Kind of if you unstar the product, it disappears. Okay, so what happened here, right? Like it might look like very futuristic. That's actual recording of the workflow, right? Like this is not pre-made video. And as I said, like ingredients of those workflow are pretty basic, right? Like we essentially expose the existing tooling through MCP servers. And there are two of them here, Angular MCP, obviously, right? Like to give access to DI hierarchy. We also did experimental playwright MCP, so the agent could interact with the browser. So there's, again, there's just this one principle that every information the human has through DevTools, for example, we can inspect the DI graph. The AI agent should have access to the same information, but we probably don't want AI agents to go to a browser, open DevTools window, and click through the menus to find the DI graph. We probably just want to expose the text file or like text, content, so the agent can consume it. Now, this might look a bit futuristic and might be looking a bit uncomfortable, right? Like because all of a sudden, what's our job, right? Like this, if those AI agents can follow exactly the same workflow as we do, well, that's kind of pretty uncomfortable. But, those workflows are not that far away. And to be honest, we could build them around the frameworks of today. Like this was built with the Angular, as you know, with the thing that is released to NPM. So on top of like playing with those workflows and working on them, we're asking ourselves a very fundamental question: what does it all means? What is this AI movement means for the frameworks, for the framework itself, and for the applications that we are writing with that? And we already see that the framework will have to change and will have to adapt. And I think there are two main forces that are pushing us to change the framework. The one push comes from actual LLMs, in the sense that we want to be a good code generation target. We see that we've got like pretty high scores on the generation flow, but we also see specific points where LLMs are kind of making the same mistake over and over again, and I will talk about it in a sec. So we want to kind of iron out those places. Then I think the applications will have different look and feel or different UI workflows. So let's talk about the framework design, so we are good citizens in this LLM, as the LLM code generation target. So what I think the most interesting part for me recently, or the thing that kind of gives me the most joy at work, is playing with this idea of LLM-driven API design. And like we were doing those large-scale changes to the framework, and every time we're planning such big change, we're doing user studies. We did user studies for reactivity APIs, we did studies for control flow, we're running RFCs and so on. And we were getting like massively, useful feedback. But setting up those user studies, thinking of the exercises, recruiting people, running those studies in a way that we are not kind of introducing our own bias, it's taking time. Analyzing results of those studies takes time. So usually a user study was taking weeks. Now, what we found out that we can run the same user studies with LLMs in a matter of hours. And the workflow we would use for the new idea or the new API, you would start by writing documentation, right? Like without writing any code, without doing any design work, you would say like, oh, this is the new feature of the framework or the new API. You write the user documentation for it, you get lots of examples. Then you get this documentation and feed it to the LLM and ask them to generate lots of those small components, for example, or like a lot of small examples of usages of this API. And it turns out that LLMs are really, really good at writing code against the APIs that we just imagined that don't exist, that they were not trained with. So again, like you ask LLMs to write me the code, you look at the results that come back. In many cases, the results will be good, right? Like the LLMs will like spit out perfect code that works with the APIs that are purely imaginative. But they will fail as well, right? Like we are seeing various ratios, but like let's say from new APIs, we are seeing, let's say, 60% to 80% success ratio on the first tries. Now, you look at the remaining 20 to 40% of cases where LLMs did fail, and you try to make sense of why this failure happened. And the first finding was that those failures are not random, right? Like they are failing in a very reasonable way. So they will usually fail if the documentation is not clear or maybe the API is confusing. So then you will try to correct the API and correct documentation, repeat it over and over again. And by following that process, you end up with the pretty good design. So, it's kind of like LLMs are writing a framework for themselves, which I find pretty fascinating. What I also find fascinating is that LLMs tend to struggle the same way the developers would struggle, right? Like we're wondering if we need to drastically change the approach to API design, but it seems like the same things that are good for humans tend to be good for developers as well. Like what is good for developers is good for LLMs and vice versa. So 2 quick examples here. In Angular, to bind to ARIA attributes, you had to use this add prefix. There's a long history why it was the case, but it was easy for us as developers to add this prefix, and LLMs were failing there quite a bit. So we fixed it in the framework, right? Like we just basically said, okay, let's remove those historical technical reasons for not having this and not have this prefix at all. LLMs are happy. I believe the developers will be better off as well. Another example was the for loop, right? Like we wanted to be concise in our design, so we have something that mimics the for loop, but we dropped the let or const prefix. But LLMs are kind of really trying to add this let thing here. They are trying to use various types of loops. So I guess we will just make this change. I don't know yet. In any case, many of the quality improvements that we did for the framework recently are coming from this process of LLM-driven design, and we probably will use it more and more. And you will probably hear me or other people from Angular team talking about it more. Okay, so that's the framework. It will change. What about the applications? I think the other force coming at the framework is people trying to write different types of applications. And we see already examples of it from the new Google search, where it's trying to build this very dynamic experience where the LLMs are actually combining or building UI on the fly as you ask your questions. Our other project that is kind of pushing boundaries here is the hash brown. Mike Ryan is doing a lot of talking on this topic, and he has very interesting ideas of what applications integrating AI might look like. Highly encourage you to have a look. Now, we also recognize that we as the framework developers are not sitting in the same place as you doing application development. So that's why we've opened up RFC recently, where we're kind of trying to solicit the feedback on the applications of the future. Well, that's all I've got for today, and I've got 6 seconds left, so I will just leave you with some call to actions. Just go and play with this stuff, right? Like I was super skeptical about the whole AI thing for a long time. There is something you need. Install prompts for your framework. That's kind of probably the best quality bump that you can get for your code generation pipeline. And if you have thoughts for the application of the future, our RFC is open. Thank you so much. Enjoy the rest of the conference.